Okay, guys, today we'll start with electrochemistry, and as the start of the electrochemistry, we'll start with those topics that you see here, which will be most likely in a part of the video. So we'll deal with introduction to electrochemistry, oxidation and reduction, writing half reaction equations, and writing redox equations, predicting the redox reaction, disproportionation, and we'll deal with oxidation number and redox reactions and balancing redox equations using oxidation numbers. The very first thing that we will discuss is the introduction to electrochemistry. So as you even may see from the word electrochemistry, it is electricity and chemistry. It's a combination of the two. It is important in the electrochemistry to first discuss or clarify what is electricity. So we are saying here it's electricity and chemistry from the chemical reactions. So now electricity is the motion of the electron from point A to point B. When we discuss the electrochemistry, we have to know that as I said, like the combination of the electricity and chemistry, there are two ways that the electricity and the chemical reactions interact between each other. So certain chemical reactions, some chemical reactions are able to produce electricity. So make it possible to the electrons to move from one point to the other point. And the other way is that electricity can make certain chemical reactions to react so electricity, it makes possible the interaction or the reaction in the chemical reaction to happen. Okay, so electricity, we'll see that. One second. Electricity can make certain chemical reactions happen, even though that in a normal spontaneous way that will not happen. So electricity can make certain chemical reactions happen that in a normal situation that will not be possible to happen. We'll see examples of two of those, and you will see why and how, and this pretty much is the two chapters of the electrochemistry unit. This is the focus of chapter 1, and this is the focus of chapter 2. So we will talk for the first part, like just as an introduction, we will talk about the chemical reaction and electricity. But let's see first what is electricity. So electricity, as I said, is electricity is the motion of the electron. So when the electrons have a path to move from object or point A to point B, then what do we see, or what do we say on this case, is that the electricity is produced. Okay. So when the electrons are moving from point A to point B, in the electricity, what usually they are using as the way to move is conductor, some sort of wires or things like that. But when we are talking about the chemical reactions, which is the second part here, what is happening is that some of the compounds or the elements are giving up the electrons, and some of the compounds or the elements are receiving those electrons. So therefore, the motion of the electrons is happening, which means that the electricity is produced. Does it make sense? So this A and B now are element A or compound A that is giving the electrons, and this A and B, point A and B, which in electricity are two different points, in the electrochemistry is an element or a compound that is willing to receive that electron that is released by element or compound A. Okay, and when this is happening, what it is called, or it's known as, the oxidation reduction reactions. So we have the element A, which is willing to give the electron, and element B, which is willing to receive the electrons. And then since the electrons are moving, then electricity is produced. Okay? So during the first part of electrochemistry that we will study, we will see that the electrons are spontaneously moving from element/compound A to element/compound B. And on the second part of the unit, what we will do is we will force the element, and I will now name them as element C, or element D, and element D, or compound element or compound D. Normally, we do not see the motion, or spontaneously, I should say, we do not see the motion of the electron to happen as element C and D are in contact with each other. So this doesn't happen. Okay, this doesn't happen. So therefore, what do we do on the second part, where the electricity make the chemical reaction happen, the oxidation reaction happen, is that it is forced, the electricity through a battery or some sorts, is it forced so that it is making the motion of the electrons to happen from element C or compound C to element or compound D. So those are the two parts of the electrochem. So you see that the chemical reaction between element or compound A is spontaneously happen, oxidation reaction, or oxidation reduction reaction, which means that the electrons are spontaneously given away from one of the elements or the compounds and are spontaneously absorbed, taken, received from the element or compound B. And the second part of the electrochemistry is where this motion of the electron is made possible as a result of electricity. So through the power of a battery or something, the electricity is making possible that the element C, in our case, is willing to, or compound C is willing to give the electrons, and element D or compound D is willing to receive those electrons. Make sense? Okay, let's take a look now to like a real example when we don't see just A and B, but we see elements or compounds that we are dealing with. So let's take a look at what is happening between zinc metal and copper 2+. So now, when zinc and copper 2+ are interacting between each other, what is happening is that zinc is giving electrons to copper, and it's giving 2 electrons to copper. And then on this way, zinc now, since it is losing 2 electrons, and then when we take it from the perspective of atomic structure, losing an atom which is a neutral, losing 2 electrons will make it so that it's becoming zinc 2+, and copper gaining 2 electrons is becoming a copper metal. So now, why is the question maybe, why do you think that zinc is willing to give those electrons, and why is copper pulling those electrons? This is because copper 2+ has a stronger pull of the electron, has a stronger pull for electrons in comparison to the zinc, which has a weaker pull for electrons. So on this way, what is happening is zinc is losing electrons, and copper is gaining electrons. And when any compound or any element is losing electrons, what do we say is that it is oxidized. And when you are gaining electrons, we say that is reduced. Now you may say that gaining and reducing, yeah, this is something that you have to get your mind around it, and this is a historical thing that we have to deal with. Just keep in mind that when you are losing electrons, you are oxidized, and when you are gaining electrons, you are reduced. And the best part of all this that we explained here is that it is happening without doing anything into the reaction, without putting anything as extra into the reaction, because zinc is has a weaker pull of the electrons in comparison to copper 2 plus, and therefore what is happening is those electrons are pulled by the copper 2 plus, making it a copper metal, and zinc is becoming a zinc 2 plus or zinc ion. So in other words, this reaction that is happening without any extra thing, it's known as to be spontaneous. Spontaneous reaction. Now, a natural question that you may have in this case is, okay, great. Logically, this sounds fair. However, how do we know that this type of reaction, this type of motion of the electrons from one element to the other is happening spontaneously? Well, for this, what it helps us is our lovely data booklet, and specifically page 7 of our data booklet, which is the table of selected standard electrode potential. And the subtitle of it is the reduction half reactions. When we take a look at the reduction half reaction or that table, we see that copper 2 plus is way above zinc on the other side of the reaction. So when and this table is sorted based on the electric potential difference of the reaction. So when we see it, then electric potential difference of a reaction is what is the potential to grab or potential to do electrical work on the electron. So if you have an element that has a higher potential energy, then the electrons will be naturally going to that element or compound. And if you have, in this case, copper 2 that is higher in potential energy than zinc that is on the other side of the reaction as negative 0.75, then the difference of potential between the two is so that allows the electrons to go to the copper 2 plus. Okay? Now, of course, that there is more into it because this reaction or the electricity is not produced just, okay, zinc is grabbing this and then, but electricity is produced when the electrons are moving into a wire. And what is happening on this case is that we create that is known as the galvanic cells. And within a galvanic cell, what we have is we have two solutions, I will say, and then we have the zinc plate and the copper plate. And here in the solution we have copper 2 plus, and they are connected with a wire. And what is happening as we connect them with a wire, the electrons are moving from zinc to copper 2 plus, the motion of the electron. And in this case, as the electrons are moving, then the electricity is produced. And within this cell, both the copper and the zinc are called electrodes. But what we have to keep in mind is that anode, and those are words that we will use all the time in this unit, anode is where the oxidation is happening. And a cathode is where the reduction is happening. So in this case, the oxidation is happening in zinc. So we can call this as the anode. And the reduction is happening at the copper electrode. So we can call this cathode. And in this unit, we will use a lot of acronyms, especially when we remember or when we are trying to remember what is happening, which one is oxidized and which one is reduced. But in terms of the anode being called, or anode being called the electrode that the oxidation is happening, I will present to you an acronym, and you may choose to remember it or not, or to use it or not, but I will say use ANOX. So anode is the one where the oxidation is happening, or if the oxidation is happening, then it is called anode. And for redox is a red cat. So it's the same thing. If the reduction is happening, then what we have, we call that electrode cathode. Or if we know that is cathode, then we know that the reduction is happening in that electrode. So up to now, we have talked about that part where the chemical reaction is able to produce electricity. And now let's see the second part of electrochemistry, where the electricity make possible for a chemical reaction to happen, which otherwise will not happen normally. So this process, the second process or the second part of electrochemistry, and this is just an introduction, guys. So this is like an overview of the electrochemistry. What do you expect? What is that you will see in electrochemistry? So this is happening through that is known as the electrolysis, okay? And if you see, electrolysis is used very often when water is decomposed into hydrogen and oxygen, and this is known as the electrolysis. So this battery, it's called electrolytic cell, or the cell that makes this possible. It's called electrolytic cell. Electrolytic cell. And we will explain this in our lessons, most likely like focused on the chapter 2 of this unit. So when you see a reaction like this, where hydrogen is broken down, it is decomposed into the elements, even though that you may not see it as what is happening behind the scene, still this is oxidation and reaction and reduced reactions. Because if we bring that equation again, so water and hydrogen plus oxygen, I'm writing it a bit like apart from each other so that we add more information into it. When we see hydrogen is +1 and oxygen is -2. And as an element or as an atom, then they are neutral, so 0 and 0. So now when we see hydrogen here is, and from +1 is becoming 0, hydrogen is gaining electrons. Gain electrons. So when it is gaining, what is happening? It is reduced. So it's a reduction that is happening here. However, when we take a look at the oxygen, on the other hand, when we see it from -2 is becoming 0, then it is losing electrons. And when it loses electrons, what do we say that is happening? It's oxidized. So even on this reaction, what is happening is that oxygen and hydrogen here, the motion that is happening of the electrons is that from oxygen are moving to the hydrogen. Okay, so because oxygen is losing, so therefore hydrogen is gaining. And just the key, one of the key things here is that when we have an element without any charge or not combined into a compound, it is with a charge 0. But based on what we said before, we have a problem here, because what do we see and what do we know is that the oxygen has a stronger pull for electrons, and hydrogen has a weaker, so this is stronger pull for electrons, and hydrogen has a weaker pull for electrons. But what we are asking here is to kind of put them out of their comfort, quote unquote, zone. So we are asking them that even though the oxygen is stronger than to pulling electrons, we are asking to give those electrons away to some element, in this case hydrogen, that is weaker than the electron. And this is even seen from the table on page 7 of your data booklet, reduction half reactions. Okay, so you can see that oxygen is stronger than hydrogen in terms of pulling or giving electrons. So as I said, even the table on page 7 prove that the oxygen has a stronger pull than hydrogen, because oxygen is higher up into the left side of the reaction in comparison to hydrogen that is on the right side of the reaction. So then this motion of the electrons is not happening naturally, but it needs to be something that will make this motion possible, available, which gives us the right to say that this reaction is a non-spontaneous reaction. It's not happening naturally, that the oxygen is giving those electrons to hydrogen. Okay, so this is known as a non-spontaneous reaction. Okay, and in order for a non-spontaneous or not spontaneous reaction to happen, a way to this non-spontaneous reaction to happen is by adding a battery into the uh, because the battery that has a potential energy is able to pull the electrons from oxygen and then send them or give it to them, make it possible for the hydrogen to receive those electrons. And this is why this cell is known as the electrolytic electrolytic cell. Okay, so what is happening in an electrolytic cell is that we have a solution and we have two electrolytes which are connected between each other with a battery. And then this battery, what it makes it possible for the electrons to be pulled by the one of the electrolytes, and in this case it serves like a bridge between electrolyte 1 and electrolyte 2, and pulls the electrons are pulled from, so electrons are pulled from oxygen, and through the power that the battery has are sent to the are sent to and are sent to hydrogen. And what is happening, even though that oxygen has a stronger pull than the electron. So when we see it in our table, oxygen, a spontaneous reaction will be that the oxygen will receive the electrons, will take away the electrons from hydrogen. But through the battery, then what is happening, it is pulling those electrons from oxygen, and it is sending them, traveling them to hydrogen. And on this case, what is happening, oxygen is becoming oxidized. So oxygen is oxidized, and hydrogen is reduced. And in terms of which one is anode and which one is cathode, remember what we say, an ox red cat. So anode is oxidized, anode is the oxidized, which means that oxygen will be anode. So oxygen will be the anode and hydrogen will be cathode. So as I said, this is just an introduction to the electrochem as to a big picture of what electrochem is and how are we going to treat and see electrochemistry in Chemistry 30. I will see you on the following lesson for today, part of the lesson for today. But for now, have a great one.